Okay, today what we're going to do is we're going to talk about compound interest, which is just a variation of exponential growth and decay. So compound interest formula looks something like this. It's A, and then it's going to be principal times 1 plus the rate as a decimal over how many compoundings to the nt. So what does all this represent? A is your amount or your total. Okay. P is the principal, which is what you start with. Okay, P is your principal. Okay, then R is your rate, and you want your rate as a decimal. So R is your rate as a decimal. Okay, is rate as your decimal. N N is number of compounds per year. So N is the number of compoundings per year. So N is number of compounds per year. And then T is time in years. So T is time in years. So the big thing is you got to think about when they say it's compounded. If they say it's compounded quarterly, that's 4 times a year. If they say it's compounded semi-monthly, that's 2 times a year. If they say it's monthly, it's 12 times a year. If they say it's daily, it's 365 times a year. All right. So let's take a look at example number one. Example number one, it says Dave invests 300 in an account at an interest rate of 5%. He makes no other deposits or withdrawals. Find out what it's in the account after 15 years. If it's compounded semi-annually and monthly. So for the first one, for A, here's the thing. Principal is going to be 300. The rate is going to be 0.05 because it's a decimal. The number of compounding, since it's semi-annually, that's going to be 2. And the time is 15 years. Okay? And the time is 15 years. So how do you do this? You plug this in, 300, and you do 1 plus the interest rate divided by 2 times a year taken to the 2 times 15. So you can polish this up, and you could do it all in one clean swoop, but if you do this part in here first, you're going to get 1.025, and then that's going to be to the 30. And when you calculate it, you get $629.27. Okay, you get $629.27. Now, what if I did it monthly? If you do it monthly for part B, the things that change is 1 plus, this is still the same. Now this is divided by 12, and this is taken to the 12 times 15 power. What does that mean? That means you run this money machine 180 times over the course of 15 years. So when you do this math, this gets you 0.00416, and then this is 180. So they run it 180 times, right? And if you do that, you're going to get $634.11. So the more you can run your money machine, the better off it is. Okay? Make sense? Great. Let's look at problem number three. Problem number three, because you guys can do problem number two on your own. Problem number three says when Amelia turned 6, her grandparents opened a college savings account for her with an initial deposit of 500 bucks. The account earns 3.2% interest compounded bi-monthly. That is important. If her grandparents make no other deposits or withdrawals, how much money will be in the account when Amelia can access it at age 18? So, with this one, we're putting 500 in for principal, right? We're going to go 1 plus the interest rate of 0.032 compounded bi-monthly. Compounded bi-monthly. So that's 2 times a month. So that's going to be 24 times in the year. And then we're going to go 24 and then time. If she started at 6 and they do it at 18, I think that's 12 years. Right? So when you calculate all this, this becomes 500 times 1.00133, and then this goes up to the 288th power, And when you punch that in your calculator, you're going to get $733.88. Okay? So that's how that works. Super simple. All right? You can do number 3 on your own. Heck, you can do 4 and 5 on your own. Because what I want to talk about next is I want to talk about when they say something really fancy like compounded continuously. When you hear the words compounded continuously, you come back with your PERT formula. Remember that one from the other day? Right. So that's when it's compounded continuously. So if you look at number 6, suppose an $800 investment is compounded continuously at an interest rate of 6%, how much will be in the account after 20 years? So you just punch this in your calculator. This is like 800, and this is e to the, I believe it's like 1.2. And when you do that, you get $2,656.09. All right, pretty easy. Let's look at probably number 7. It says find the balance of an account after 5 years if $1,200 is initially invested at a rate of 12.5% per year compounded continuously. So with that one, you're going to put in 1,200 for your principal, right? And then you're going to say e to the 0.125, and then this is going to be for how long? How long is it going to be? It's going to be for, what did we say? We said 5 years, I think. Yep. So times 5. So when you do this, you get 1,200 e to the 0.625. And if you put 1,200 bucks in, leave it alone for 5 years, and it earns interest continuously, you get $2,241.90. Okay. So that's how you do the compound interest and continuously compounding interest. Do the rest on your own, and I'll see you in class. And may the force be with you.